right, so let's take a look at our lab questions from Chapter 13, our repeated measures ANOVA. I gave you a question that's not in the book. That's a really important question, but it isn't in the book to answer. Question 2, parts A and B. 6B, all 4 steps, plus the post hoc, which means that you know what the decision's going to be if we're doing a post hoc, right? So anyway, let's walk through them and see. The out-of-book question on the lab sheet you saw says, the repeated measures ANOVA can be viewed as a 2-stage process. What is the purpose of the second stage? So I said this several times in the lecture videos. The purpose of the second stage of this ANOVA is to remove the individual differences, the error from the individual differences out of the denominator. Remember, the numerator between treatments is already individual difference free because we're recycling the same people over and over and over, so we're comparing people to themselves. So again, the numerator is already free of between subjects variance or error due to individual differences. So one more time, the purpose of the second stage is to remove the error from individual differences, that between subjects variance, out of the denominator, and then just use whatever error's left over. All right, question number 2. Said that a researcher conducts an experiment with 4 treatment conditions with 12 scores in each condition. A says, if it was an independent measures design, how many individuals were needed for the study and what are the degrees of freedom values? Well, if it is an independent measures design and we have 4 treatment conditions with 12 scores in every condition, we know that we're going to need 1 participant for every one of those scores. So we're going to need 12 people plus 12 more people plus 12 more people plus 12 more people. So we know that K is 4 treatment conditions, and we know that we're going to end up with, for an independent measures, 48 people. 12 plus 12 plus 12 plus 12. 48 folks. And then the question says, all right, and so what are the degrees of freedom? Well, if it's an independent measures, remember our degrees of freedom are going to be between treatments, which is K minus 1. So 4 minus 1 is 3. So for part 2A, we know that we've got a total of 48 people in the study for a grand total of 48 scores. We know that our degrees of freedom between treatments is going to be K minus 1. So 4 minus 1 is 3, and then our degrees of freedom within treatments is what we use for error in our independent measures study. So we know that that's the summation of the degrees of freedom for all the groups put together. So the first group has 12 scores in it, so its degrees of freedom is 11. The next group is 11, the third group is 11, the fourth group is 11, so 11 plus 11 plus 11 plus 11 gives us a degrees of freedom within treatments of 44. So we've got 4 treatment conditions we're going to need 48 people to get that done. Degrees of freedom between is 3, degrees of freedom within is 44. And then 2B asks, well, what if we did this as a repeated measure study? Well, we know that we're only going to need a grand total of 12 people, because we're going to have 12 in the first group plus 12 in the second, but it's the same 12 in the second, and it's the same 12 in the third, so we only need a grand total of 12 people. So while we needed 48 folks before, we only need 12 people here now, but we still end up with a grand total of 48 scores. Remember, this capital N is telling us the number of scores in the study, not the number of people. That's why I wrote this down, to really emphasize that. This study used 48 people, this study used 12 people, but we have a grand total of 48 scores no matter which way we did it. So our degrees of freedom between treatments would be the same. There's still a K of 4, so our degrees of freedom between would be 3. But remember, for repeated measures, we're not using within treatments for error, we're using degrees of freedom for error. Well, how do you calculate degrees of freedom error? Look at your formula sheet, it's right inside the box. You get your degrees of freedom within treatments, and you subtract out of that your degrees of freedom between subjects. You see your degrees of freedom between subjects is simply little n minus 1, so 12 minus 1 is 11. So our degrees of freedom as a repeated measure study would be 3 and 33. There are other ways to get those answers, but that's the most direct way. You could also end up using these and subtracting backwards to get these values. So there's more than one way to get the right answer, but this is the way, the most direct way of getting there. So that's question 2. And then 6B was to do all 4 steps of the ANOVA as a repeated measures. So in the preparation stage, you had quite a bit of prep work to do with this problem. You needed to know K was 3. You needed to know the little n values. Little n1 was 4, little n2 was 4, little n3 was 4. Capital N value was 12. You needed that. You needed your person totals. Person total 1 was 24. Person total 2 was 15. Person total 3 was 6. Person total 4 was 3. And then, because we know we're doing a post hoc, we also know we're going to need the sample means. We might as well get that done in the preparation stage. Sample mean for the first treatment condition was 5. For the second treatment condition was 4. For the final treatment condition was 5. So 3, 4, and 5 for the means. Step 1, stating our hypotheses. I'm not going to bother to rewrite that right here. The alternate hypothesis is at least one treated population mean will be different from another treated population mean. The null hypothesis is treated population mean 1 equals treated population mean 2 equals treated population mean 3. So the same way we've been writing that for both chapters, the only thing we can do. Step 2, we'll talk through them in order, even though we can't do them in order. The problem said to use an alpha level of 0.05. We will have discovered that our degrees of freedom between treatments is 2. Our degrees of freedom for error was 6. So over to 2, down to 6, 0.05 level, your critical F should be 5.14. Now for step 3, the calculations. I'm just going to walk through these values. If you're not able to get the values I'm sharing with you, send me a line and I will give you a breakdown on that calculation. And or go back and watch me do them in the lecture videos if you're getting lost here. But please ask if you need it. So sums of squares. Sums of squares between treatments 8, within treatments 94, between subjects 90, error 4, and sums of squares total 102. So again, going down the column, 8, 94, 94, and 102. The degrees of freedom column. Degrees of freedom between treatments 2, within treatments 9, between subjects 6, between subjects was 3, error was 6, and DF total is 11. So again, the degrees of freedom column is 2, 9, 3, 6, and 11. Our mean of squares, remember, it's just a way of saying variance. So our between treatment variance, or between mean squares between treatments, is 4. Our mean squares error was 0.67 when we round it. Remember, report rounded values, calculate with the full values, yes? So when you do that, you get an F ratio. You have an F of 2 and 6 equals 6.00. So our F statistic, or F ratio, is 6. Our critical F was only 5.14, so we are in the shaded area. So we're going to reject the null hypothesis. If you wanted to report that in APA, an F of 2 and 6 equals 6.00, semicolon P less than 0.05. And then lastly, the post hoc. So we needed to look up our Q value. So remember in that table, you go over to K and down to your degrees of freedom for error. In doing that, you should find that your Q value is 4.34. So 4.34 times the square root of 0.67 divided by 4. That value, when reported properly, is 1.77. So the HD was 1.77. HSD, I'm sorry. So difference between mean 1 and mean 2, not significantly different. Difference between mean 1 and mean 3 is significantly different. The difference between mean 2 and mean 3 is not significantly different. Remember, you want to report every comparison and tell me if it's significantly different or not. So that's your walkthrough on these lab questions from Chapter 13. Again, you need any help, send me a flare, throw me a line, and we will get you the help you need. Otherwise, keep practicing. We are getting close to done, gang. So hang in there. Just dig deep. I know it's getting tiring for all of us. We'd be tired even if we weren't in these crazy times, right? But we'll get there. All right, everybody, hang in there. Take care of yourselves and each other, and we will see you for the last series of videos for Chapter 14.